Today we're going to do the least squares regression line. Here's what's been covered so far. Scatter plots, a graphical display to investigate the relationship between two quantitative variables, and correlation coefficient, a numerical measure of this relationship. Remember, the correlation coefficient measures the strength and direction of the linear relationship between two quantitative variables. We suspect the relationship between these two variables is linear, and we would like to come up with a line that best summarizes this relationship. Here is a scatter plot for the data points given in the table below. So we have this scatter plot of y versus x. X is along the x-axis, y is along the y-axis, and here are our points. Using your ruler on the scatter plot below now, try to determine the best and worst fitted lines. So using our ruler, we're going to try to come up with a line of best fit and like a worst line of best fit. So my line of best fit I'm going to do in blue. And you're just going to put your ruler and try to estimate your line of best fit. So something like that. Okay. And a worst line of fit could be something like this. Okay. So what do we look for in a best line? So we want it to represent the points well, and the line is close to the points. What will we do with our line once we find it? We're going to predict y values for a particular x. Our primary purpose in coming up with a line that best summarizes the relationship between x and y will be to predict a typical or average value of the response variable y for a particular value of the explanatory variable x. We will measure the error or deviation or residual by how far off we are in predicting the typical y value. That is, we will measure error, also known as deviation or residual, as the vertical distance between the data point and the line. The data point gives us the real y value, and the line gives us what the model we are using predicts the y value to be. Since residuals are errors, how should we measure the best line? So we're going to go through and go ahead and explain the situation here. So I have 3 observations. So I have observation 1, which has x1, y1. I have observation 2, which has x2, y2. And I have observation 3 up here. And here is my line of best fit. Okay, so let's talk about observation 1 first. Observation 1 has a vertical distance to y hat 1. That's what we're going to call this. This is known as the residual. So here our residual is greater than 0 because it's above the best fit line. Because we would have y1 minus y hat 1 is greater than 0. So here y hat 1 is an underestimate. So this y hat 1 is an underestimate. Here, I have my observation 2. The distance from y hat 2 to my observation 2 is here. The residual is greater than 0, is less than 0 because it's below the best fit line. That is because y2 minus y hat 2 is less than 0. And y hat 2 is an overestimate. So y hat 2 here, since it's above the actual data point, is an overestimate. And then our final one, observation 3, the residual is 0. So for this one, the residual equals 0 because y3 minus y hat 3 equals 0. So my observed equals my predicted. So how we find a residual, going off what we just did here, is y minus y hat, which is also the observed minus predicted. The smallest sum of residuals will always be 0, and that sums of the squares of the residuals. So here, let's go over some formulas we will use to find the least square regression line. So the equation of the least squares regression line is y hat equals b sub o plus b1 times x. The formula for the y-intercept coefficient, which is your BO, your initial y-intercept, is y bar minus b1 times x bar. And your formula for the slope coefficient, which is b1 equals r times the standard deviation of x over the standard deviation of y. So these are 3 formulas you're going to use to find your least squares regression line.